computer is complex enough that we play a lot of games and then you have so many controls and then you have combinations. Why should I use external controller? That was one thing. And also my motivation was for like, if you control manually, then you cannot do cool things. Like I cannot make it fly from here to there. I cannot follow a person. I cannot like detect objects and then do something on it. So you might have seen a lot of products available online, like selfies or videos taken by the drones and then follows the person. So like a lot of varieties available to it. But the basics is this. The moment you go to autopilot, there is 4 important points. I'll just touch upon it so that to get the context. So first is state estimation is you have an environment and you have your quadcopter and you want to know whether it is stable, whether it is in the ground, whether it is in the which altitude it is, and which attitude, which is like which direction it is leaning towards. All those is state estimation. You are estimating where the copter is, or like knowing the properties or knowing the values of its gyroscope, all those things. I'll come to that part later. And second thing is control. As he said, like control is, it can be either via external controller or when it comes to autopilot, right? It mainly deals with a PID controller. They talk about it. PID is basically, is it like noisy, too noisy? So this control is basically very similar to machine learning concept, if you would have learned. In machine learning, what we try to achieve is you basically have a lot of data, history data, and you need to make predictions, but there is always an error, and your goal is to minimize the error. And the error, computing error, cost function, all those is different for different types of algorithm. So very similarly, the controller, the control, it takes in the parameters from IMU. There is a lot of sensors. It takes in the current position and then it controls the copter, stabilizes it basically. So that is control. We'll go into deeper, like what is the parameters, everything. And mapping is basically, now you know the copter, now you know how the copter is, but you want to know where the copter is in this room. So example, I'm in this room at the end. So I'm in this room at the end. So if the copter is over there, it cannot go straight. So depending on the environment, like you need to basically map the environment, like how the room looks like, how does the environment of the copter. So for this mapping, you need to bring in video streaming, images, image processing. You need to give eyes to the copter basically. And planning is you have a source and then you need a destination. Let's say from here, I want the copter to go to the exit. That's the planning. So that's all it's there to it. So I'll dive into code or like few concepts which are used by the copter, and this is specifically for this Crazyflie API, but I've written in a way that you can easily integrate it with any other copter. So there are different states, as you can see. One is connection and disconnection, and if there is a failure in connection and if there is a loss in connection, you need to say who is the callback and what it should do. I hope everyone knows callback. Like callback is, if there is an event, let's say it throws an event and then the callback is some code or a function that handles that. So I have this. And the callback by, I mean, here if you looked at it, right, like we can even go here. So this is visible, right? So this Crazyflie is basically an external API. For these actions, I am adding multiple callbacks. Here, let's say for this connection, if it is connected, I'm adding a method. I'm adding a method which says, you set the commander in my context is you command the copter what it should do, and just do a test flight and add other callbacks. That's it. So this is callback. I mean, compare Java language or some other language, how you would send a generic commands or in design patterns, you might have heard a command pattern, but it's very cumbersome in Java or something. But in Python, as we know, it's like you just simply pass in a function, which I think is cool. And so the callbacks is added to the events, and the Crazyfly API, what it does is once it knows it is connected, which means you have a radio, which I'll show, like the radio sends some data to the copter, and then if the copter sends acknowledgement back, then it is connected. Then after that, it will call all the callbacks which you have registered for it and then execute it. In our case, it was just one method, but basically you can add list of callbacks. So this I found very interesting because it is extensible and then you can do multiple things with it. Imagine once I connect to the copter, I can just make it fly, or rather I can bring the cameras on. Like let's say you're mapping the environment, there are other cameras which is monitoring your copter. All these things you can just add it to the callbacks. Okay, so I've talked about like on an event of a copter, we are doing something. Now, the part I'm going into is controlling the copter with your keys. So for this part, I've used just Pygame. It can be replaced by anything. So this Pygame handles the key events. So whenever you press a key, you can do something on it. So in this case, if it is key pressed up, I'm sending increased thrust, and then if it is down, decreased thrust. So can you hear me? I keep on disconnecting. I feel so. So this is also a callback which is defined in my case. Like the callback can be any class or anything that have a notify method. Within that, you are passing a parameter. This parameter is a string. So this is pretty interesting part actually. If you look here in the keys, right, I had like 10 if-else keys. For each if-else, I'm actually managing if this is the key, do something. But very similar concept. When you press a key up, basically this commands.increase thrust or commands.decrease thrust. If you get the commands, what you need to do, that is also defined in another file basically. Here, right? So visible, right? So for each notification event, this here event is simply a string. So it's like I just defined a string. These are the commands that I can give to the copter. And on every event, I can say what to do. So in this example, right, in this context, we'll take a thrust. I mean, I'm talking about thrust and like, yeah, different things. Should I explain that like before what it is so that you guys can know what it is? So in aerodynamics, the copter, right, like the thrust is basically how much of force or the force produced by the propellers. Propellers is called like the fans ends the copter. When it rotates faster, the copter goes up. So they call it like weight to weight and then proportional to thrust. That is how it decides how faster the copter can fly. And roll is basically you roll it to the sideways, and yaw is in the same side, but you turn the direction. This is simply explaining picture, but this is how the copter thing works. So in order for it to move, in our car, we just move forward. But for this, if it changes the speed of different propellers, then it will fall. Basically, it needs to lean front and then increases the force so that it moves forward. So that is basically a pitch. So if you see, it leans and then it moves towards the direction. Okay? So this is a picture depicting the same thing. Yaw is on the plane, like in our ground, and pitch is basically leaning left to right, and roll is basically the opposite side of the pitch, and thrust is the force which is produced by the propellers. Okay, so now back to this. So I've mapped the keys very similar to the games. If you press up and down, you increase the speed. So this is the same thing. And then left and right, you just turn the same thing as you move a player in a game. And AWST, that is the one which decides which direction your player is moving. Very similar to that, I've done that. Okay. So this is the key combination. It's a lot, but I couldn't change this code into a single line, basically putting a dictionary, putting the callbacks into the dictionary and then calling that. But rather, I was successful in doing that in this commander. If you see here, this handlers is basically a dictionary, and then which have a list of commands, and each command is basically taken from an event. So if I ask increase thrust, like if there is an increase thrust event, then I get the callback increase thrust method, and then I call this. So in our case, you increase the value of the thrust. It is a value, pure integer value given to the copter, and then you send the command to it. So very similarly, if you see decrease thrust, it decreases it, and then roll left and roll right. Everything is very similar. And we'll go to send commands. Okay, so this is the command which it takes. Like it takes roll, pitch, yaw, thrust, all the values, and then it decides the copter position and movement. So I've been talking about like different things. Probably I'll just put it in a right way. First, I have a whole control copter file which controls the copter. I'll go into detail where like I've controlled it with GUI. You can control it with voice, and you can control it with autopilot mode. Autopilot is like you need to figure out what is the thrust, yaw, everything based on the current values. So this is the control copter. So I take in arguments. It can be autopilot, or it can be a GUI, or it can be a voice control. And then for each thing, voice control, I have a separate thing. We'll go into that later. If it is either controlled via GUI or GUI or voice, I need to connect to the copter first. Here I'm connecting, and then I'm configuring the interface. So first I have control copter. Then interfaces is something which interacts with the copter. So here I'm using this separately so that it makes connections or disconnect, like dealing with the callbacks. So interface between your program and the copter. And commander is something which sends commands to it. And I also have something called GUI manager, which handles the GUI events. So by this way, I can replace the GUI manager with anything. And if I don't use a GUI manager, I can directly send commands to the commander and then call the copter to fly using voice or some other means. So I think I've made some sense. So this is the layout. So I can replace anything with anything. Like Pygame, instead of that, you can replace it with some other thing. Okay. So overall, you connect to copter, use Pygame for listener, and then key press, you invoke an event, and then you use the callback to control it. And the callback handles accordingly, sending the proper values. So if you imagine you connecting to some other different fly or a drone, you just need to change the commander. That's it. So I can probably show you. So this is a drone I have. Like I had a huge bird, I missed it. I couldn't bring it, but this is the copter I have. It's called Crazy Fly. It's very tiny. It's so agile. I'll just connect and see. Let's see it works. And this is the radio connect, which is like an antenna you can use so that like you can control it with within 1 mile or something. But this is basically from Nordic Semiconductor, and it is bidirectional. So you send commands to the copter, and the copter acknowledges with the data. So, not voice recognition. So there is a Wi-Fi, lot of Wi-Fi running inside. So there might be a disconnection, but let's see. I'm just connecting here. Like, I'm not sure whether you're able to see it. I'll just try making it fly. It's broken. The propellers are broken. So basically, I'm trying to dynamically decide the propeller's speed and then balancing it. But that's a long way to go. So the best thing I found programmed was halt. It just goes and disconnects, and then, oh shit. So it's so fragile, and it's just too fast. Like, I can reduce the thrust value so that it just flies a little, but I cannot hover it because it's so unstable. Like, the weight of this one side is broken. So basically, this tilts down, and then it just goes in some other direction. So this, whatever I've done now, this is a UI handler. Like, I couldn't do away with a terminal handler. So that's why I had a Pygame. Very simple UI, handles a key and then sends events. But also one more thing, right? Like, they have the Crazy Fly, their organization, they have shipped a Python client to it, which basically runs the whole client, which is a UI, and then you can connect to the external joystick and then control it and then see the values. So I've been talking about autopilot, and then you need to estimate the state. But what do I mean by that, right? Like, so in order to know the state, I just have one picture now. There is something called gyroscope and accelerometer, which decides its velocity, and accelerometer which decides which way it's accelerating. Imagine something like a cube, like a perfect box. Within that, you have a ball. There's no gravity to it. The moment you start pushing it, it's like if I have a box, the moment I start pushing, it leans right side, correct? So which means the accelerometer knows it is moving in this direction. And the moment I start pushing here, the ball touches the sphere walls to my side. So which means the accelerometer knows which direction it goes. So similarly, gyroscope is another sensor which rotates by itself, like something like this. It is used in aircrafts, like a lot of drones everywhere, and even bots which balances itself. If you would have seen the videos, the gyroscope is in place. So the gyroscope is another thing which measures your velocity across Z, X, and Y region. Basically, like my velocity towards this direction, and also left to right, and the altitude. So this is the gyroscope. When I fly the copter, I'm also taking the log, which is basically what is the values of the sensor. So if you see accelerometer, it has 3 axes. Minus means like towards me, and then plus means towards you. And gyroscope is also 3 values, but this is like altitude and this direction. So now you get the picture, right? Like gyroscope, if it is stable, the Z-axis, it should not have any velocity. Or if you're trying to hover it, the accelerometer should not have any values across all the directions. So you have this log, and now you form an algorithm which takes in values, and then directly, like whenever I see a log, I know what is the state it is, and I need to figure out what is the commands that I need to send, which is like thrust, yaw, pitch, and roll, so that how this value can become stable. Okay, so that is what I mean by state estimation using this sensors, which is generally called IMU, inertial measurement unit. So this logger I've defined with API that you can go and look in GitHub. So next, I'll show one more thing. It's all the same repo. Okay, so I'm using external API. It's called with AI. You can use Google APIs or IBM's voice recognition. And what it does is here I'm converting my voice into text. Let's see whether I'm connected to internet, I'm not sure. Hey, are you there? Oh, sorry. So here, here I have a recognition which converts my sentences into a command. Why I have such system is basically, let's go here, just a second. Because the voice recognition system is bad, so that like you cannot just issue a command, say connect, but it is good in a sense that, hey, are you there, or see you later, or can you please stop? It is good, and then it can recognize that. And what I'm doing is, whatever you say, sentences which I'm converting into some specific command, and I'm sending it over to Copter. So basically I have a TCP server running in a Copter, which is a server which listens for messages. And I have a voice control system which reads my voice and then converts into command and sends it to this person. So imagine now, extrapolate this. I can run my Copter, connect it here, and then any one of you can start a service which sends the messages to my socket, so the Copter can be controlled by you, basically. So let's see how this works. Okay. Hey, are you there? Hey, are you there? It's bad. Are you there? Come on. I'll say some other commands probably. Okay, this is better. Are you sleeping? Are you sleeping? Oh, man. Are you sleeping? Okay, so if I send this, it reads the messages here, and then it connects. And then if I ask him, like, can you fly? And then it just flies. I also have some other system which takes in the commands, in the Copter perspective, look at it, takes in a command, do some action, and then responds with a message. So this basically talks. So now how I see the system is, it's not just anyone can control the Copter, but the Copter is something like intelligent that you talking to it, and then it is responding to you. I mean, I have to define that, right? Like right now, I've defined only these commands: connect, disconnect, fly, and then ping, just to see whether it's working. But you can define anything. You can ask it to do a stunt, but you have to write code for that. So I can show here, like voice control. So this, right, like if it receives a connect, like this takes precise commands, and then it tells, I'm trying to connect, sir, something like this. So it's basically like a very nice system. I think everyone loves Jarvis, Iron Man, right? Sort of similar to that, but yeah, it is too slow. Let's try for last time. If not, we can try later probably. Are you there? Are you there? Yes, finally. It works. I'm not sure whether you can see it. There was a test flight. I had the very less value, but I can increase it and then ask it to fly for a higher values. See you later. Actually, I muted. That's why we couldn't hear anything. See you later. See you later. It's fine. Just bye, exit. So it responds to that, and then it disconnects, and then you can do actions on it. So we've talked about multiple things. One is like how do you control a copter, and how do you send events to some commander, and then how the commander can respond to a particular a drone. So in this case, right, like I can replace this drone with any bird. I had a bionic bird, but I couldn't bring it. And the commander helps in that. You can just change the API to send what values it takes. And interface, right? Here the interface is GUI, but rather you can change it voice, as I said. And also there is autopilot I have, but it's not perfect. It just slams somewhere. So there you get the picture, right? And there is one more part which is happening. You take in the values and then analyze what the copter state is now, and then you try to optimize the commands which you are giving to it. And human-computer interaction, like here I have a array and then converting it to comments, but rather you can use NLP to do that. So this is not it. I mean, Python, I've used it as a tool, but there are a lot of things which I've seen as a nice things. Like one I've shown you callbacks, and that there are other things like optional parameters, and a lot of things which I can talk about, like most of people know. But if it is Java, it was entirely different. So basically here, like as I said, like I tapped into multiple repositories, and then used that Python client, used just the repository which asked me to connect. And there were libraries like Pygame or something else which didn't work in 3.5 version, but I just tapped into it and then removed things which is not needed by me, which I think you would not be able to do in some other languages or frameworks, but you can, but it's harder. So the main thing is it's not just learning Python for me. This opened up space where like I started learning about like how the copter flies, which means this relates to a Newton's theory. Every action have an equal reaction. Basically, you push the copter. I mean, you propel and then it pushes. So something like that. And there is something called your Euler's formulas. There are like a lot of things. Like I started reading about physics. And then there is, of course, a lot of mathematics involved, which I haven't started, which everything converges into one place, I see. If you want to build intelligent systems, right, you cannot just go with, like, I know this language, and then I can program it. No, not at all. So the program, how we write, is becoming complex. Example, recently there is an autopilot self-driving car. Uber launched it in Pittsburgh. If you see, that is also simpler. It takes in, it uses something called LiDAR. It senses the environment, sends radars, and then adjusts its position. We do not know how the self-driving car works, but the moment I've seen machine learning course, like I've started, like I always wanted to start, but the starting point was like Coursera, Professor Andrew Ng. The moment you see it, you will be like surprised, because recommender systems is very simple. And machine learning self-driving cars is simpler. It just takes the data and then adjusts its position based on the error. So I think it's not just learning the language. For me, it's like you need to start a journey. And for me, the journey spawned in physics and mathematics probably sometime soon. And aerodynamics, like still I do not understand much about gyroscope and like accelerometer values dealing with it. I have to explore. But even thrust, yeah, I did not know. And I've been using a lot of languages, and then we build systems, right? Like I've built a lot of systems, distributed systems. I've worked in multiple projects, Android projects, all those things. But I somehow found my joy in this, some copter. The moment you scored, it flies. I think that was happiness for me. But I would suggest, like for you, you have to find a similar thing where like this makes you happy, and then you learn things around it. I didn't want to dive deeper into it because I just wanted to surprise or like give a salt of like what I'm doing, or like just make you think. I hope I made some sense, and like sort of like you should start exploring. That's what I wanted to do. But if you have many questions, like how things work, if you have questions or feedback, just ping me. And I'll be here for 2 days. You can just catch up with me anytime. Thank you so much. Thank you. Yeah, if we have time, like, is there questions? Any questions?
Any questions?
This was wit.ai.
Sorry? Yes. Yes. Which one?
EMU thing.
No.
It's local. I mean, you don't have to connect to an API or anything, and you can just train the acoustic model. It's better than this.
Okay, sure, I'll try.
Definitely better than this.
Okay, I chose with AI because in the internet, it takes in the command and then it's process and then sends intent. So basically, I can have a remote system and then start running it. That's why I picked it. But sure, I'll give it a try. I'll connect. Okay, sure. Thank you.
Any more questions?
CMU Sphinx. Thank you. So his question was based on the sensor data, did I do some calibration or how I did it? I followed a blog or like a tutorial where like it takes in the values and then calibrates it with the formula with tan, sine, cos, everything. I couldn't understand heartfully. But I tried. It sort of worked, but it didn't because my copter is broken. But the thing is, using ML, I think you can achieve it. I'm just exploring. I haven't done everything yet. So we know the end state of the sensor data, like z-axis should be 0. And then you send all random commands. And then you see the error converging to 0. And then it goes to that. Basically, ML, right? Like they teach how the robots to walk. And they teach how the copter to fly. Basically, random things just send in. And then minimizing the error. That's how it is done. I have to explore. I'm just like in the path. Thank you.
Any more questions? No, we are over with it.
Sure. Catch up with me later. If you want to explore or try this, you can just come later and then ask me. And sure, like drop me feedbacks if you have any. This is my email ID, not sure it's visible. dineshkumar_csc@hotmail.com. And if you want to know more about the code, have a look at it in the Git. It's available. Thank you again.
Thank you, Dinesh. It was nice having you here. We have open space going on. The two topics for open space are interactive data plotting with Loki and Python Express. It's in lecture hall 3. Anyone who wants